Okay, so in the last video we computed the log probabilities, these conditional probabilities you see here down on the test predictions tab. And these numbers up here from cells, from rows 25 through 44, that is the log probability of each of these words occurring given that it's from the app class. And then the second set of log probabilities down here from rows 48 to 67, those are the log probabilities of each of these words occurring given that they're from the other class. So now how do we actually make our tests, how do we actually make predictions and validate our naive Bayes model here? The way we do that is super simple. We're just gonna make another row here, and we're gonna so this is like each word in that first tweet and the log probabilities of each word occurring in each tweet given that it was from that particular class. So all we have to do is just add those up. So I'm going to put equals sum and add all those up, everything, close parentheses, do that, and I can just drag this down now. Now we have these conditional probabilities for all the words in each tweet. I'm going to drag this actually down through both of these sets of log probabilities, and I have those numbers now. So I will now clear these out because that's just filler space, and then I'm going to go up here, and now it's time for us to make our predictions and see how well our model actually worked. So I am going to put an equal sign, and this is super simple. All we have to do is check to see if, open parentheses, we're going to do a quick logical test. We're going to say, okay, if this log probability here, if that log probability is greater than this log probability, then we are going to say it is about the app. So we're going to return that value if the probability in C25 is greater than the probability in C48, we're going to return app. And otherwise, we know it's got to be flipped, right? The other way around. The chances of them being exactly equal is slim to none. So we know that it's going to be the other category. And I'm going to close parentheses, click enter. Now what do we have up here? All right, we're correct about that first prediction. So if I drag this down, what are the chances we're correct about that second one? It says we ended up being correct. And if I go through here, actually we did really well. Our model, if we look at just the app, we perfectly predicted all of these. So there were no false negatives, right? All of these happen to be about the app, and our model says, hey, they are about the app. If I continue to drag this down, what do we get? All the way through other, okay, we're doing pretty well here. We got a couple of false positives, right? It says this one is about the app when it's really not about the app. Similarly, right here, but it looks like we got 18 out of 20 correct. We have 0 false negatives, so we're always detecting that it's coming from the app, that it's about the app when it actually is about the app. And we have a couple of false positives here, saying like, oh look, we're saying this is about the app when it's really not. And so there you have it. That is a simple way to validate the model. Now I'm going to talk about another type of validation technique in the next video called cross-validation, and that's the actual way that people go about validating any type of classification model similar to naive Bayes.